Hello everyone. Previously we had discussed on the this one, detect and remove loop in the linked list algorithm, right? So today we'll be discussing the last topic in this particular playlist, nothing but the last algorithm in the linked list based algorithms basically. So this will be cloning the linked list with a random pointers, right? So this is one of the this one important algorithms that I have found. This has to be discussed, right? So this may be asked in the interviews as well. So this will be implementing in many questions, many problems as well, right? So this is one of the very important problems I wanted to discuss. So this will be basically cloning the linked list with a random pointers, right? So let's get into the definition part. So a clone linked list with a random pointers is an algorithm that is used to create a deep copy of the linked list where each node has two pointers, right? So a clone linked list with a random pointers is an algorithm that is used to create a deep copy of the linked list where each node has the two pointers. One is next and the another one is random, right? So the next pointer points to the next node and the random pointer points to any node in the list or none, right? So what is our main goal here? The goal is to create a new list with the same structure and connections, right? So this is fine, I believe. So let's go with the explanation part. Now we have the idea, right? A clone list with the random pointers is an algorithm used to create the deep copy of the linked list where each node has two pointers. One is next and another one is random. Next points to the next node, random points to any node in the list. It might point to any node in the list. The goal is to create a new list with the same structure and connections, right? So let's move on with the explanation part here. So unlike the normal linked list, so here each node also has a random pointer, right? So each node also has a random pointer that can point anywhere, right? So that can point anywhere. Just remember this. So we need to copy not only the sequence but also we need to preserve the random relationships as well, right? So this is very important, right? So what are the steps to clone? Basically let's discuss the same thing. Initially what we'll do, we'll insert the copies of each node, right, after the original node. So we'll insert the copies of the each node right after the original node. This will be the first point. So we will assign the random pointers to these copied nodes. So we'll be assigning the random pointers to these copied nodes basically. Next we'll be detaching the original and cloned lists into the two separate linked lists, right? So this is important. What we'll do, we'll detach, means whatever the pointers that we have attached in the previous step, so we'll be detaching the original and the clone lists into the separate linked list so that we can get later the original and the clone list we can get later, right? So that is the reason we'll be detaching the original and the clone lists into the two separate linked lists here. Finally this ensures we get the exact deep copy without losing the random connection. So we can get the clone list, right, separately basically from the original. So this ensures we get the this one, we get an exact deep copy without losing the random connection. So this is fine, I believe, right? So let's try to implement the same thing whatever we have discussed now in the form of code, or let's start writing the algorithm. So here the first step would be, let's define the node structure, right? So I'll just go with here class node. So this is fine, we are going with the Python, right? So this is fine. The first step would be initialization or the constructor part. I'll just go with init here self. So this one will be self dot val. Let me assign this one to the val, right? So this one we have to call here as well, as we are making use of the val. This is fine. Now I'll just go with next pointer. So this one will be self dot next equals, initially it will be none. Also we'll be going with a random pointer, so this one will be self dot random. So this one, let me set this one to the none as well initially, right? So this is fine, I believe. So next let's do one thing, let's go with a function clone linked list, right? So let's write the function to clone the linked list basically. So this one will be def clone, so this one will be linked list, so this one of head basically, right? So this is fine. If this one not head, so this is fine. If not head, so then we will return none, right? Then we will return none. So this is fine, man. So the first step would be here, we have to insert the copied notes right after the original notes accordingly with the explanation, right? So let's do one thing. Let me do one thing. I'll just initialize current to head, and also as I've said, we have to insert the copied notes right after the original notes, right? So let me write the while loop here. While of current. So this one, we have to create the copy of the current node. How can we do that? Let me initialize the new node, or let me assign the new node to the node of we are creating the copy of the current node, right? So I'll just go with current dot value of the current. So this one is fine. Next we have to link the copy to the next of the current, meaning here new node dot next. So this one is current dot next. So this is also, sorry, current dot next. So this is fine, man. So the next part would be we have to place the copy after the current. So this one will be current dot next. So this one will be new node, man. This is fine. Finally, we have to initialize or assign the current to the new node dot next, meaning we have to move to the next original node. So this one will be current equals new node dot next. So this is fine, I believe, right? So I'll just get out of this one entirely. Now what we have to do, this is the second step. Basically, I said that during the explanation part we discussed that we have to assign the random pointers to the this one. So the second point, this one, we have inserted the copies of each node right after the original node. We are done with this part. Now we have to assign the random pointers to these copied nodes, right? So how can we do that? Let's try to do the same thing here. So let me assign current to head initially, then again let me go with the while loop here, while of current. So what if current dot random, basically. So I'll just go with if current dot random, then we have to copy the random to the clone. So this one will be current dot next dot random. So let's assign this one to the current dot random dot next. So this is also fine, right? So the next step would be let me assign current to current dot next dot next. So this is fine, man. Yep. Now let's do one thing. Let's move on with the next step. We are done with assigning the random pointers to the copied nodes, right? So here this line number 44, current dot next dot random, whatever I have assigned this one to the current dot random dot next, we are just copying the random to the clone here. So finally what we are doing in the line number 45, we are just skipping to the next original node. So this is fine. We are on the right path, right? So now we are left with the last point, meaning we have to separate the original and the copied list, basically. This one, detaching the original and the clone list into the two separate linked lists. That's what we need to do, right? So what we need to do now, we have to separate the original and the copied list. So again, so now let me assign current to head again. This is the third point. So now clone, I'll just go with clone head. Let me assign this one to the head dot next here. This is fine, man. So let me do one thing. Let's quickly go with while of current. So this is fine. Let me assign copy to the current dot next. This is fine. So this one will be current dot next. Let me assign this one to the copy dot next. So this is also fine. Now let me write the simple if condition. If copy dot next, now copy dot next, let me assign this one to the copy dot next dot next, meaning here we are just fixing the clone links here, right, by assigning the copy dot next to copy dot next dot next, right? So this one current dot next to copy dot next, whatever I have assigned, this one line number 50, basically we are just restoring the original list here. So after fixing the clone links, we have to assign the current to current dot next here, right? So this one finally. So I'll just go with the current, let me assign this one to current dot next. This is fine, man. Finally we are left with only one thing, so we have to return the this one clone head, right? So I'll just go with return, let me go with clone head. Yeah, we are done with this part, man. So now let's go with the helper function just to print the list with the random pointers, right? So this is for the example usage. Basically I'll just make use of the helper function or the helper method. Yeah, so this one will be print list of, let me go with the head here. This is fine. So within this function, first we need the result variable, right? So I'll just assign this one to the empty array. So let me go with while loop here, while head. So this is fine. RAND, I'll just go, let me assign this one to the head dot random dot value. So this is fine. If head dot random, else I'll just go with a none. So this is fine. So this one will be result dot append. So I'll just go with f followed by, so this one I'll just go with head dot value. So we are just making use of a string interpolation here, right? So this one is fine. Let me go with the random equals, so RAND is the variable I have considered, right? So I'll just go with the RAND here. So this is fine. So no need of one more flower bracket here. This is fine, right? So this one as well, here as well, here this is actually this one parenthesis. So I have considered double this one. Actually this is fine, man. I have to close the parenthesis as well here. Yep, this is fine. Now what we need to do, we have to assign head to head dot next, and finally what we need to do here, so we need to return the result as well. So I'll just go with return result. So this is fine, man. So we are done with the 3 steps. So we are left with the final step, nothing but the example usage. Let's see, right? So we have to print something for the this one interactive purpose, right? So let's go with the example usage here. So this one will be if name, so this is equal to, so let me give here within the strings main actually. Yep, this is fine. So then let me do one thing, let's create the nodes, right? So I'll just go with n1 n2 n3, let me assign this one to the node 1. This is fine. N1 n2 n3 we have considered. N1 let's assign to the node 1, n2 let's assign to the node 2, and n3 let's assign to the node 3. So this one will be node 2 comma node this one 3, right? So this is fine. The next step would be let's connect the next pointers as well. So this one will be n1 dot next comma n2 dot next comma n3 dot next. So this is fine, I believe. This is fine. N1, or let's do one thing, let me assign n1 dot next and n2 dot next to n2 and n3, right? So this works. Basically we are just connecting the next pointers here, right? So this is fine. Next we have to connect the random pointers as well. So that's what we need to do. So this one will be random accordingly with the explanation part, right? So we went with, previously we had discussed the same thing, right? So this one will be n2 dot random. This is also fine. This one will be n3 dot random. Finally this one will be equivalent to n3 comma n1 comma n2. So this is fine, I believe, man, right? So this is fine. After connecting the random pointers, let's make use of the print just for the sake of interactiveness, right? So I'll just go with print here. So this one, let me go with original, this one list basically. So this is fine. So let me call the print list helper function here. Whatever we had written earlier, helper method or the helper function print list, let me pass the n1 here. So this is fine. So we are just printing the original list, whatever we have considered, right? So this is fine. Now let me assign the clone this one object to the let me call here clone linked list function here. This is fine. Let me pass n1 again. So final step is let's print something for the let's print the clone list basically here. So original list we are printing in the line number 73. We have to print the clone list as well, right? So we have written the algorithm for cloning the this one linked list with a random pointer itself, right? So let's go with the clone list here. Let's go with the print list. So this is fine. Finally let me pass cloned here. Let me pass cloned here, right? So this is fine, man. We are done with the coding part basically. We are done with the coding part. So this is fine, I believe. Yep, this is fine. We are done with the coding part. So now we are done with the algo. So let's I hope the algorithm part is completely clear. Let me do one thing. Let's run the code, right? So we have to get the output original list 1 comma random equals 3 initially, right? So random equals 3, 2 comma random equals 1, and 3 comma random equals 2, accordingly what we have what example usage we are going with, right? So n1 dot next we have assigned to n2, and n2 dot next we have assigned to n3. So 1 comma random equals 3 initially, 2 comma random equals 1 initially, and 3 comma random equals 2 initially. So the clone list remains same, right? So we are just cloning the list, so we have to get the same output, right? 1 comma random equals 3, 2 comma random equals 1, and 3 comma random equals 2. Let's check the same here. So I'll just come here. Let me copy the file name. So let me q control J, clear screen, 1 second. This will be python file name dot py. So here see, we are getting the output 1 comma random equals 3, which is absolutely correct, 2 comma random equals 1, which is absolutely correct, and 3 comma random equals to 2, which is absolutely correct. So clone list and the original list we are getting different, and the output we are getting is absolutely correct, right? So basically what's the output here? We have got the original list, this one, basically the output that we have got here, this one, right? So the original node 1, so this one, original node 1 points random this one randomly to the node 3, this one. The original node 1 here, this one points randomly to the node 3, right? So that's what random equals 3, which is correct. Clone of 1 also also points to the clone of 3, right? So clone of 1 also points to the clone of 3. Same goes with the 2 and 3. See here, this one, original node 2 points to the this one, points randomly to node 1, and clone of 2 points to the clone of 1, right? So this is fine. Finally original node 3 points randomly to the node 2, clone of 3 points to the clone of 2, which is absolutely correct, right? So the cloned list perfectly mirrors the original. The cloned list perfectly mirrors the original, right? So this is the output that we got, which is absolutely correct. I mean, we have got the desired output, right? So this is fine. So we are done with the this one, cloning linked list with a random pointers algorithm. Now let me summarize whatever we have learned so far, and let's finish this one, right? So we are done with the linked list algorithms. So this is going to be the, I mean, this was the last algorithm in the playlist. This is going to be the last algorithm in the playlist, basically, in simple terms, right? So next we'll be discussing the algorithms on the different topic, right? So we have discussed on the array algorithms, string algorithms, sorting algorithms, searching algorithms. We are done with the linked list algorithms as well, right? So now we'll be going with the stacks and queue algorithms next, basically from tomorrow. So we'll be starting with the monotonic stack, and we'll be continuing with monotonic queue, expression evaluation, as well as the stock span problem algorithm. So this is purely based on stacks and queue, right? So next we'll be continuing with the stacks and queues algorithms, basically. So this is going to be the last algorithm within the linked list algorithms playlist, right? So let me summarize whatever we have learned so far. Just try to remember this 1 or 2 points, right? So the clone list with the random pointers algorithm creates a deep copy of the complex linked list. We know this one, right? So we solved this one. So we have successfully written the algorithm. We have solved this one in the big O of n time. So the time complexity of this algorithm is big O of n, and So big of 1 extra space, meaning the space complexity is big of 1. So the time complexity and the space complexity of the algorithm that we have written is big of n and the big of 1 respectively, using the 3-step method, right? So using the 3-step method itself, right? So first here, this one the first step was basically inserting the copies. The second step was assigning the randoms, right? So the third step was basically detaching the list. So that's what we did here, right? So this approach basically ensures both next and random pointers are preserved, right? So just keep this in mind. We went with a 3-step method. One is inserting the copies, the line from the line number 32 to 39, and the second one is for this one. Second one was for the assigning the randoms until here, right? Until line number 46. From the line number 47 to the line number 56, basically this is detaching the lists, right? So this approach basically what it does, it ensures both next and the random pointers are preserved. So we are done with this particular algorithm, right? So let me close this one. So as usual, next, as I have said, from the tomorrow we'll be discussing on the stacks and queues algorithm, right? So we'll be moving on with the this one, stacks and queues algorithm. We'll be starting with the monotonic stack algorithm. So now, for now, this is it. Thanks for watching, guys.